Hello and welcome to Algebra 2 Lesson 48. In this video, we're going to learn about rational expressions and rational functions. So the majority of you worked with rational expressions back in Algebra 1. At this point, you just need to know that working with a rational expression is in many ways identical to working with fractions. So let's just start out by talking about fractions a little bit. So we should know at this point that a rational number is the quotient of two integers. So some examples of a rational number, something like 2/3. So I have an integer 2 over an integer 3. Something like 5/7, integer 5 over an integer 7. Something like -2/11, an integer of -2 over an integer of 11. So very easy to define a rational number. The one restriction is that what? We cannot have the integer 0 in the denominator, because division by 0 is considered undefined. So just like we have rational numbers, which are the quotient of two integers, we have rational expressions. So a rational expression is the quotient of two polynomials. So just to give you two examples, let's say it's something like 6x squared minus 5, and this was over x cubed. This is a polynomial. It's a binomial in the numerator. This is a polynomial. It's a monomial in the denominator. So this is a rational expression. Or as another example, let's say you had something like 3x to the 7th power minus 5x cubed plus 2x minus 1 over, let's say you just had something like 4x to the 5th power minus 7. So you've got a polynomial in the numerator over a polynomial in the denominator. So this is considered a rational expression. Now, in your textbook, you're probably going to see something that looks a little bit confusing. They will start out by saying that a rational expression is what? It's P over Q, where Q does not equal 0. And I want to talk about this for a minute because we're going to go into a section where we're talking about this denominator not being allowed to be equal to 0. So P is a polynomial and Q is a polynomial. But Q lies in the denominator. And we say Q cannot be equal to 0 because, again, we can never divide by 0 because division by 0 is undefined. So specifically, what we're saying is that if we have a rational expression, generally speaking, we have variables in our denominator. Sometimes you won't, but in most cases you will. So we want to say that that variable cannot be equal to any value that results in the denominator becoming 0. So I want to start out by just talking about finding the domain of a rational expression. So I want you to recall that the domain, we talked about this when we talked about functions, is the set of allowable x values. So the domain, or the set of allowable x values of a rational function, includes all values that result in a non-zero denominator. So what's allowable here for x is anything that does not result in the denominator being 0. Now, for the first problem we're going to look at, and we're just going to find the domain, it's very, very simple. If I look at f of x is equal to 3x squared minus 2 over x, and I say, well, what's the domain? What is the domain? All you need to think about if you get this problem is look at the denominator and say, what can I not plug in for that variable? Because again, I don't want the result to be 0. Well, it's very straightforward here. I just cannot plug in a 0. If I plugged in a 0 for x, I'd be dividing by 0, which is not allowed. So the domain would be the set of all x values such that x does not equal 0. Okay, and again, I put this in set builder notation. So let me just write this out. This is the set of all x. We have this such that that real number you choose, which is x, it can't be equal to 0. So I can choose any other value that I'd like. All right, so that's your domain for this one. For this one, it's going to be a little bit more complicated. We have f of x is equal to, we have x squared minus 4x over 36 minus 4x squared. What I want to think about is a value, or it could be values, for the variable x that would result in this whole thing becoming 0. So in order to do that, what do I need to do? I need to set up and solve an equation. What I need to do is say, well, 36 minus 4x squared cannot be equal to 0. Or I could put equals 0, and then if I find a value or values that make this equation true, then they have to be excluded. Because if I plug in for x there and I evaluate, I'll end up with 0, and I don't want that for my denominator. So how could we solve something like this? I know we talked about the quadratic formula in Algebra 1, but we haven't really got to it in Algebra 2 yet, so I'm going to stick with things that we can solve via factoring. So this is the difference of two squares. This is 6 squared minus 2x squared. So we could factor this into 6 plus 2x, that quantity, times 6 minus 2x, that quantity. We set this equal to 0, and we can use our zero product property. So in other words, this factor here, 6 plus 2x, would be equal to 0. And then or we'd have 6 minus 2x is equal to 0. Let's go ahead and subtract 6 away from each side of the equation. So this would cancel. Let me scroll down and get some room going here. And what we're going to have is 2x is equal to negative 6. Divide both sides by 2, and we'll get that x is equal to negative 3. Over here, let's subtract 6 away from each side of the equation. This will cancel. We'll have negative 2x is equal to negative 6. What we'll do is we'll divide both sides of the equation by negative 2. And we'll have that x is equal to 3. Let me put my or there. So x equals negative 3 or x equals 3. So you have to remember what we're doing here. Let me erase everything. So let me just put this off to the side as like a little note. We solved 36 minus 4x squared equals 0. And the solution set contained two elements, negative 3 and 3. So what that's telling me is that if I plug in a 3 or a negative 3 in for x there, so if I plugged in a 3, let's just start with that, you would get a 0 as your denominator, and that's not allowed. So you would have 36 minus 4 times 3 squared is 9. So 4 times 9 is 36. So you get 36 minus 36, which is 0. It would be the same thing if I plugged in a negative 3, because you'd have negative 3 squared, which is positive 9. Again, you get 36 minus 36, which would be 0. So then the domain here, the domain, is the set of all x values such that x does not equal negative 3 or 3. So negative 3 or 3. So let's take a look at one last one. So we have g of x is equal to 4x plus 12 over 7. So in this case, is there going to be any restriction on the domain? No, there's not. I don't have a variable in the denominator, so I'm basically good to go. So for something like this, we would say the domain is the set of all real numbers. Okay, pretty simple overall. All right, so now let's talk about kind of the next topic that comes up when you talk about rational expressions for the first time. How can we simplify a rational expression? Well, it goes back to simplifying a fraction. So if I have something like 2 over 4, we know that we can cancel the greatest common factor between numerator and denominator. Now, a lot of us at this point, we know that 2 and 4 share a common factor of 2. So you can say, okay, 2 divided by 2 is 1, 4 divided by 2 is 2. So you end up with 1/2 like that. But if you didn't know that off the top of your head, which you're not going to know this in the case of a lot of rational expressions, you would factor it. Right? So you would say, okay, well, 2 is a prime number. So really the best I could do is say 2 times 1. And 4 is 2 times 2. So then when you look at it like this, it's obvious that you cancel a common factor of 2 between numerator and denominator, and you're left with 1/2. Okay? So this is basically the process that we're going to use to simplify a rational expression. Well, let's go ahead and take a look at the first example. So we have 12a minus 16 over 12. So the first thing I want to do is I want to look at that numerator and I want to factor out the greatest common factor. So between 12 and 16, it's going to be 4. So if I pull a 4 out, I'll have 4 times the quantity. Inside of parentheses, I'll have 3a minus 4. Then down here I have 12, which is divisible by 4. So I could write this as 4 times 3. Now, one thing I want you to realize is that this is multiplication right here. This is multiplication. So this 4 is a factor. And this quantity, 3a, okay, 3a minus 4 is a factor. Okay, 4 is multiplying that entire thing. So we are able to cancel common factors. This is a factor, and this is a factor. So between the numerator and denominator, they share a common factor of 4, so that can be canceled. So what's left now? You have the quantity 3a minus 4. I don't need the parentheses anymore. I can just get rid of them. So 3a minus 4, and then over just 3. Now here's where students make a gigantic mistake. We just talked about common factors. And I know it's confusing because there's a minus sign in here, but it's this entire thing that's being multiplied by 4 there. So those two are factors. Here I just have 3a minus 4 over 3. There's no common factor between the numerator and denominator other than 1. Right? I could do this if I wanted to. I could put this in parentheses and say times 1. I could put this times 1. And then if you wanted to cancel 1 with 1, it wouldn't do anything, right? It's still just equal to 1. But that's an example of something you could actually do. But because I don't have any common factors, I can't just go through and do this. I can't say, okay, well, I've got a 3 here and a 3 here. That's a very common mistake that you're going to see. Let me just label this as a common mistake. And you see it in Algebra 1. You definitely still see it in Algebra 2. It's something you have to realize that is illegal. Your answer here, your simplified result, is 3a minus 4 over 3. Right? Nothing else you can do. All right, let's take a look at the next problem. So we have x squared minus 9x plus 8 over 6x minus 6. What you want to do here is you want to factor the numerator and denominator and see what you can cancel. So in the numerator, we have a trinomial. So we're going to factor that as the product of two binomials. So it's an easy scenario. I have x squared, so I'm going to put x here and x here. And then just find two integers whose sum is negative 9 and whose product is positive 8. Well, that would be negative 8 and negative 1. Then we'll put this over. We have 6x minus 6. I could factor out a 6 from that. And I'd be left with x minus 1 inside of parentheses. So again, this is multiplication here. The quantity x minus 8 is multiplying the quantity x minus 1. So this is a factor, and so is this. Then down here, this is multiplication. 6 is multiplying the quantity x minus 1. So this is a factor, and then so is this quantity x minus 1. So do I have a common factor between the numerator and denominator? Yeah, I have the quantity x minus 1. This can be canceled with this. They're common factors. So what I'm left with is x minus 8 over 6. Now, this is something that you really need to understand. You might be given a second task on a problem like this, and they might say state the restricted values as well as to simplify. Is this right here, this x squared minus 9x plus 8 over 6x minus 6, the same as x minus 8 over 6? Not technically, because if I think about this right here, x cannot be equal to 1. Because if I plug the 1 in there, 6 times 1 is 6, and then 6 minus 6 would be 0. So with this original rational expression, we have a restriction where x cannot be 1. In this simplified version right here, x can be whatever you want because there's no variable in the denominator. By canceling a common factor, we have lost some information. Okay, we have lost some information. So if you're going to be given a task like this, you want to find the restricted values before you do any simplification. Okay, so we would say that in this case, x cannot be equal to 1. All right, let's take a look at the next example. So we have 3x cubed minus 14x squared plus 16x. And this is over 15x cubed minus 39x squared plus 18x. So we want to simplify here. So in the numerator, what can I do to factor? Well, you would notice that everything has an x, so I could pull that out to start. And I would have 3x squared minus 14x plus 16. And this is over. In the denominator, everything has a 3 that's common, and everything also has an x. So let's pull out a 3x, and I'd have 5x squared minus 13x plus 6. Now what I'm going to do is factor this and this, each of those into the product of two binomials. So in the numerator, let me kind of scroll down and get some room going. I have 3x squared minus 14x plus 16. So I'm going to factor this using factoring by grouping. If I think about it, I want two integers whose product is 3 times 16, which is 48, and whose sum is negative 14. So I know I need a negative and another negative. So think about some factors of 48. We've got 1 and 48, 2 and 24, 3 and 16, 4 and 12, and then 6 and 8. If I had negative 6 and negative 8, that would work. So I'm going to rewrite this middle term here. I'm going to say this is 3x squared minus 6x minus 8x plus 16. We'll put this equals. Let me scroll down and get a little room going. From the first group here, I could pull out a 3x. I'm going to be left with x minus 2. From the second group, to match the signs, I'm going to pull out a negative 8. That would leave me with x minus 2. So I have that common binomial factor of x minus 2. And I want to bring that out. So if I factor that out, I have x minus 2, that quantity, times a quantity, 3x minus 8. And so this is the factorization. So let me just copy this. Okay, so let's drag that up there. We have this x that's outside. So we have x times the quantity x minus 2 times the quantity 3x minus 8. That's your numerator. Now let's work on the denominator. So I have my 3x, and then 5x squared minus 13x plus 6. Let's factor that. So I want two integers whose product is 5 times 6, or 30, and whose sum is negative 13. That one's really easy. You do negative 10 and negative 3. So you would have 5x squared minus 10x minus 3x plus 6. Again, I just used these two integers to rewrite that middle term. So then I'm going to factor by grouping. So from the first group, I could pull out 5x. I'd be left with x minus 2. From the second group, I could pull out a negative 3, and I'd be left with x minus 2. So I have that common binomial factor of x minus 2. And so what that's going to give me is the quantity x minus 2 times the quantity 5x minus 3. So I'd have 3x times the quantity x minus 2 times the quantity 5x minus 3. All right, so let's erase all this. If I wanted to know the restricted values before I cancel anything, I would set this 3x times the quantity x minus 2 times the quantity 5x minus 3 equal to 0, and I'd use my zero product property to get a solution. Now you can do that if you want, and you'd find your restricted values. Because once we start canceling things, you're going to lose information. Okay, you're going to lose information. So if you're asked to do a simplification and also to find the restricted values, here's where you would do that. You would find the restricted values, and then you would cancel, okay, afterwards. So between the numerator and denominator, what are the common factors? We see that we have an x here that we can cancel with an x here. Then we have the quantity x minus 2 that cancels with the quantity x minus 2. So what I'm left with, this is gone. I have 3x minus 8. So no need to keep it inside of parentheses. 3x minus 8. Then over. Now we have 3 times the quantity 5x minus 3. And we keep this one inside of parentheses because this is multiplication here. And again, don't make the mistake of going and saying, well, I can cancel this 3 with this 3. You can't do that, okay? It doesn't work that way. This is multiplication here. So these two are factors. But up here, this 3x and this negative 8, those are not factors. That's a subtraction problem. So if I had 3x minus 8 multiplied by 3 like that, well, then I can cancel this 3 with this 3. But that's not what we have here. Okay, so please be very careful, very cautious when you're canceling things. It's got to be multiplication. If I go back up here, you can see that this is multiplication and this is multiplication. This is multiplication, this is multiplication, this is multiplication. So this cancels with this. Those are common factors. And this cancels with this. Again, those are common factors. So in the numerator, I'm just left with this, which is what I got, 3x minus 8. In the denominator, I'm still left with a 3 multiplied by the quantity 5x minus 3, which is what you have down here. So you end up with 3x minus 8 over 3 times the quantity, 5x minus 3. All right, let's take a look at one more problem. So we have 6x squared plus 9xy minus 2xy minus 3y squared. This is over negative 3x plus y. So how would I factor the numerator here? Well, I could use grouping. It's a 4-term polynomial. In the first group, I could pull out a 3x. What I'd have left is a 2x plus a 3y. In the second group, I could pull out a negative and then y. So what I'd have left is a positive 2x and then a positive 3y, so plus 3y. So you can see that you have a common binomial factor of 2x plus 3y. So let's put this equals. In the denominator, I still have negative 3x plus y. And so let's go ahead and factor this. So I pull out that common binomial factor in the numerator. I'll have the quantity 2x plus 3y. Then times the quantity, you'll have 3x minus y. And this is over. You have a negative 3x plus y. This 3x minus y looks similar to negative 3x plus y. The signs are just different. When the signs are different but you have the same terms, they end up canceling and becoming negative 1. It's kind of like having 5 over negative 5. Right? It's the same thing, they're just opposites. So these would cancel and become negative 1. So it's the same concept here. And to prove that to you, what I'm going to do is I'm going to enclose this inside some parentheses, and I'm going to factor out a negative 1. So keep the numerator the same. You have the quantity 2x plus 3y times, this is multiplication, the quantity 3x minus y. So each one is a factor. So this is the factor, and this is a factor. Now in the denominator, if I pull out a negative 1, so I put a negative 1 out in front of parentheses, the signs would just change. So this would be 3x, and then this would be minus y. So from negative 3x, it becomes 3x. From positive y, it becomes negative y. Now, this is multiplication. So negative 1 is a factor, and so is the quantity 3x minus y. Inside of parentheses, it's being multiplied. Now, it is completely obvious when I cancel this with this that I'm left with this. Okay, I'm left with that negative 1. So if you need to do that a few times for it to make sense for you, go ahead and do it. But the quicker thing to do is to realize that if I have this and I have this, if I cancel them, I'm going to get negative 1. You have 3x and negative 3x. So basically the same thing with the sign is different. You have negative y and positive y. Same thing with the signs are different. So if you cancel that, you're going to end up with negative 1. So my result here, in the numerator, I'm just going to have that 2x plus 3y. In the denominator, I have a negative 1. So I can put over negative 1. But if we divide by negative 1, really I don't need the fraction bar anymore. I can get rid of that. I can put a negative 1 out in front like this, or I can just use the distributive property and say I have negative 2x minus 3y as my answer.